Good morning, students. My name is Venkatesh Rao. I'm a lecturer in physics. Today, I'm going to explain the lesson thermodynamics. So, in this lesson, I'm going to explain the what is thermodynamics and three laws of thermodynamics. First of all, I'm going to explain the thermodynamics definition with example. Thermodynamics means it is a science which deals with the transformation of heat energy into other forms of energy or vice versa. Now, transformation of heat energy into other forms of energy. The best example for this is thermal power plant. In thermal power plant, when we burn the coal, lot of heat energy is generated and the heat is transformed to electrical energy. Okay, na? Now, vice versa means when the electrical power is supplied to iron box, the iron box generates the heat. So this is the thermodynamics. Now I'm going to explain the three laws of thermodynamics. First law of thermodynamics is zeroth law of thermodynamics. Second law of thermodynamics is first law of thermodynamics. And the third law of thermodynamics is second law of thermodynamics. Up to class 12, these are the three laws we have in the thermodynamics. Now, zeroth law of thermodynamics. The definition of zeroth law of thermodynamics is when two systems are individually equilibrium with the third system, then the initial two systems are also in thermal equilibrium. For example, if two systems A and B are individually equilibrium with the third system C, then the two systems A and B are also in thermal equilibrium. Here thermal equilibrium means, I will tell you with an example. When a person get fever, if you use the thermometer at its peak point, at the point of the final reading, the body of the person and the thermometer both are in thermally equilibrium. That means temperature is equal. This is the zeroth law of thermodynamics. And now I am going to explain the first law of thermodynamics. The definition of first law of thermodynamics is the heat energy is supplied to a system is equals to the sum of the internal energy or change in internal energy and the work done by the system. Formula is dq is equals to dw plus du or du plus dw. Here dq represents amount of heat, q represents heat, u means internal energy, dw or w is work done by the system. Now the example for this is solar energy means the sun gives the heat to the plant and the plant gets the photosynthesis and plant grows and the internal energy of the plant also increases and plant grows. Plant grow means work done and the internal energy is change means delta du. The heat energy is giving uh, from the sun to the plant. Okay, so this is the first law of thermodynamics. Now second law of thermodynamics. There are three statements in the second law of thermodynamics: Clausius, Kelvin and Planck statements are there. Now I'm giving the one statement I'm giving. Clashes statement I'm telling. The definition of this clashes statement is: it is impossible to transfer the heat from lower temperature body, lower body temperature, lowest lower temperature of body to higher temperature body. Okay. The example for this: ice cube cannot transfer energy or heat energy from ice cube to surroundings without external working any external agency. Okay. That means we cannot transfer the heat energy from colder body to hotter body without working any external agency. This is the clashes statement. Students, hope this video is helpful to you. Thank you very much for watching this video.